In this video, I'll be going over inverse trig functions. Before we get to the specifics of inverse trig functions, let's just recall some of the basics of regular functions. So when we talk about inverses, one way to think about it is that the domain or the inputs becomes the range, or the outputs, and vice versa. So the domain becomes the range. I'll write it with arrows. Domain the domain and the range swap. Okay, so typically the x value is the input and the y value is the output. So for the inverse, the y becomes the input and the x becomes the output. So x and y swap places. And so for trig functions, what we want to remember is that if I have a regular trig function, the input for a trig function is an angle. The output is a value or coordinate. If we're talking about the unit circle, sorry, I'm running out of space. The value is an output of the value. Sorry, the output is a value, a numerical value, or a coordinate if we're talking about the unit circle. So if we're talking about the inverse, these swap places. For inverse trig, the coordinate is the input, the angle is the output. That's the big thing to remember with this. So in a regular trig function, we input an angle, we get out a coordinate or a numerical value. For an inverse trig function, we input the coordinate or the numerical value, and the output is the angle. So things are swapping places here. Okay, so that's the first big thing to remember. Now let's think about how we must restrict the inputs and the outputs for a trig function, for an inverse trig function. Okay, so let's look back over here at this graph of the sine function, and recall that when a function is 1-to-1, it passes the horizontal line test. Okay, so if I draw a horizontal line, it's going to hit this function, the graph of this function, in two positions. This means this is not 1-to-1. Okay, and the reason we care about a function being 1-to-1 is because if we took the inverse of this function, sorry, let me be more precise. If a function is not 1-to-1, when we take its inverse, the inverse will also be a function. So, in other words, this graph right here is not 1-to-1. That means its inverse is not a function. So we need a function to be 1-to-1 in order for its inverse to be a function. So what we do is, looking at this sine graph, notice how it's only defined from -pi/2 to pi/2, and it should be parentheses there. Okay, so if I just look at this portion of the graph, that portion of the graph is 1-to-1. No matter where I draw a line, it's only going to hit that graph in one position. See, it's not hit. The dotted part is not there. So we're restricting the domain of this function so that when we do take its inverse, it will give us a function. So that's the key thing to remember here. So this statement here, it says y equals sine inverse of x, means sine of y equals x. So just the x's and the y's are swapping places, where these values are swapping from each other. And so this is maybe a little hard to understand, so let's go through a couple of examples here. So this example says, find the exact value of each expression. So one last thing I want to hammer home. So the first thing we said was the inputs and the outputs swap places. So we are no longer inputting an angle into the inverse trig function. We're inputting a coordinate or a numerical value, and the output is an angle. So all of these, since these are all inverse functions, we want the output to be an angle. Okay, so that's the first thing. And then the second thing is that we are restricting the domain for sine between negative pi over 2 and pi over 2. So we restrict that for the original function. So that means the inverse will have outputs in negative pi over 2 to pi over 2. If negative pi over 2 over pi over 2 is the input for the original function, that means it's the output for the inverse function. So to answer these questions, these are asking for given angle in negative pi over 2 to pi over 2. That satisfies this statement. So the first one says sine inverse of root 3 over 2 over 2. What this is asking is what angle in negative pi over 2 to pi over 2 has a value of root 3 over 2. That's what this question is asking. So you want to think about, well, on the unit circle, when does sine equal root 3 over 2? Well, if I draw the unit circle, sine is positive root 3 over 2 up here and here. So that's 1/2 comma root 3 over 2. And that angle is pi over 3. But it's also has that value at 2 pi over 3. Which is negative 1/2 comma root 3 over 2. So which of these angles do I need to use? Well, if I think back to what the range must be, it must be between negative pi over 2 and pi over 2. So negative pi over 2 is down here, and pi over 2 is up here. So for this first question, the answer is pi over 3. That answers this question that I asked. What angle in negative pi over 2 to pi over 2 has a value of root 3 over 2? And again, there are two locations on the unit circle, but we only want one of them because we are restricting what the value can be. All right, number 2. We say this as arc sine. This is the same thing as sine inverse. That's just another way you'll see the inverse of a trig function. So this is saying what angle in negative pi over 2 to pi over 2 has a value of, now instead of root 3 over 2, we're going to say negative 1/2. So when does sine have a negative value between negative pi over 2 and pi over 2? Well, it must be in quadrant number 4. And when is the y value negative? It's going to be right down here. And those coordinates are root 3 over 2, comma negative 1/2. And that angle right there, you need to be careful because we might initially think that that's 11 pi over 6, but that's not in this range that we're considering. So 11 pi over 6 would be if we start here and go all the way around to pi over 6. The other way to do it is to go clockwise, and that angle, the coterminal angle there, is negative pi over 6. So this is negative pi over 6. Again, it is in the range of negative pi over 2 to pi over 2. And we wanted the sine value to be negative 1/2. Okay? And then the last one says sine inverse of negative root 3 over 2. That is going to be down here. That is 1/2 negative root 3 over 2. Again, we might initially think, well, that angle is 5 pi over 3. But that's if we go counterclockwise. We want to go clockwise, and so we're going to say negative pi over 3 here. All right. A lot going on in this page. Feel free to pause and rewatch if that was a lot of info. But let's go through the inverse trig functions for cosine and tangent next. So cosine, quite similar. The only difference for cosine, or the main difference, is that we restrict this between 0 and pi here. So 0 and pi is how we restrict the domain. So what that means is the output for cosine inverse is in 0 to pi. And if you think of that on the unit circle, 0 to pi is just the top half. Okay, so that's 0 to pi. Okay, so all of our angles, all of our outputs for the inverse cosine questions are going to be angles that are between 0 and pi. All right, find the exact value for each expression. Cosine inverse of -1. This one is saying what angle has a cosine value of -1. Okay, so if we think on the unit circle, cosine is -1 over here. Okay, that angle, the coordinates are -1, 0, and that angle is pi. So this one is equal to pi. The next one, when is cosine equal to -√2 over 2? Well, -√2 over 2 occurs in two places, here and here. That's -√2 over 2, comma √2 over 2. And then in quadrant 3, that's -√2 over 2, comma -√2 over 2. So there's two places that have an x value that is -√2 over 2. The angle in quadrant 2 is 3 pi over 4. This angle is 5 pi over 4. But only this angle here, 3 pi over 4, is in the range that we want. So this is 3 pi over 4. Okay, and then the last one, when is cosine -1/2? Well, cosine is -1/2 at this position up here. That's -1/2 √3 over 2, and that angle is 2 pi over 3. Okay, this would also occur in the third quadrant, but in the third quadrant, that is not between 0 and pi here. All right. And lastly, inverse trig functions for tangent. So looking at the tangent graph here, this is actually between -pi over 2 and pi over 2. That's 1 to 1 everywhere. So we restrict this between -pi over 2 and pi over 2. So the domain restriction for tangent and sine are the same. They're both -pi over 2 to pi over 2. So we'll go through this in much the same way. Sorry, there's an ambulance. I don't know if you can hear that. All right, find the exact value of each expression. Tangent inverse of 0. In other words, this is saying what angle has a tangent value of 0. When is tangent 0? Well, looking at the unit circle, remember tangent is sine over cosine. So that ratio will be negative when sine is 0. Sine is 0 on the unit circle down here and here. But remember, I want this to be between -pi over 2 and pi over 2. So that's just those areas on the unit circle. So this is going to be at 0 radians, and that those coordinates are 1, 0. So at that position is when I have a tangent value of 0. So this will be 0. I'm just going to put radians so we know that that's an angle. Next, arctangent of -1. When is tangent equal to -1? Tangent is -1 here and here. This is at √2 over 2, comma -√2 over 2. When I make a fraction with those two values, I get a -1. Similarly, this is -√2 over 2, positive √2 over 2. Those will also give me a fraction equal to -1. The angle in quadrant 3 is 3 pi over 4. The angle in quadrant 4, well, I could say 7 pi over 4, but that is not in the range that we want. So 7 pi over 4, if I add 2 pi to that, or I'm sorry, we want to subtract 2 pi from that. we're going to get negative pi over 4, and that is in the range. So this is negative pi over 4 that we want. And then lastly, when is tangent equal to negative root 3 over 3? On the unit circle, that's in this position right here. This one might be a little hard to see, root 3 over 2, comma, that should be positive, root 3 over 2, comma, negative 1/2. And if I do y over x there, sine over cosine, y over x is negative 1/2 over root 3 over 2. The 2's cancel. I get negative 1 over root 3. But then rationalize this, I get negative root 3 over 3. So that's the angle we want to look at. And again, that's 11 pi over 6, but that's not in the range, so we want to say negative pi over 6 here. So this is negative pi over 6. All right, these are going to take probably a little bit of practice because there's a little bit of nuance, and it's easy to get tripped up here. The last thing to look at in this video is how we do composition functions. So composing the composition of a trig function and its inverse, or an inverse trig function. So recall when we are doing composition functions, we could say, let's say I have f of x equals 3x plus 1, and g of x equals 2x cubed, I guess. Actually, I don't want to do that. I don't want to deal with a cube. Let's say 2x minus 5. So if I do f of g of x, what that means is I'm taking the g function and I'm inputting it into the f function. So wherever I see x in the f function, I'm putting g. So this will be 3. Instead of x, I'm going to put 2x minus 5 minus 1, which is the g function. Okay. Similarly, I could say g of f of 2. Now what this means is put 2 into the f function, and then whatever I get, put that result into the g function. So f of 2, do it over here, f of 2 is equal to 3 times 2 plus 1, so that's 7. So what I'm going to do is I'm now going to say g of 7. 2 times 7 is 14, minus 5, I get 9 here. Okay, so that's just a quick refresher on composition functions. So let's go through what happens when we have trig functions and inverse trig functions. So find the exact value here. Okay, so on the inside part, this is saying sine of negative pi over 4. That's just the regular function saying at negative pi over 4, which is down here, what is the sine value? Those coordinates are positive root 2 over 2, negative root 2 over 2. So the sine value at negative pi over 4 is negative root 2 over 2. So negative root 2 over 2. So now this is saying find sine inverse of negative root 2 over 2. And now we're just going the opposite way. Now it's saying what angle gives me a sine value of negative root 2 over 2? Well, I'm kind of just going back to where I started. Now it's saying what angle gives me this sine value, and it's this angle right here. So in this particular instance, we end up where we started. That will not always be the case when we do the original function with its inverse, but it is in this case. All right, the second one says sine of cosine inverse of 1. So this is saying, when does cosine have a value of 1? So cosine is positive 1 right here, and that's at 0 radians. So this is 0 radians. So now what we want to say is, what is the sine value at 0? And this is saying when the angle is 0, remember this is an angle, and I know it's an angle because I have a regular sine function. Angles go into regular sine functions, or any regular trig function. So when that angle is 0, what's the sine value? Well, the sine value is just 0 here. So this is 0. All right, couple more here. This next one says cosine of tangent inverse at root 3 over 2. So that inside part is saying, when is tangent equal to positive root 3 over 3? Did I say 2 on accident? Root 3 over 3. So that is in this position. That's at pi over 6. And we kind of did this above. But these coordinates are root 3 over 2, comma 1/2. If you did y over x and simplified, we would get root 3 over 3. So the inside part of this composition is pi over 6. So now what I want to do is say cosine of pi over 6. What is the cosine value at that angle? And it is this thing right here, root 3 over 2. Okay. And then lastly, arcsine of tangent of pi over 4. So tangent of pi over 4 is saying what's the coordinate at that angle pi over 4 for tangent. And at pi over 4, we have root 2 over 2, comma root 2 over 2. That's this. For y over x, that's going to give me a value of 1. So this tangent of pi over 4 is equal to 1. So now I want to say arcsine of 1. What angle has a sine value of 1? Well, sine is equal to 1 up here, and that angle is pi over 2. So this whole thing is equal to pi over 2.